Question number 9 says, the stabilizing dosage of Inocor is established at a rate of 14 ml per hour. The dosage range being titrated is 5 to 8 micrograms per kilogram per minute. The patient weighs 103.7 kilograms, and the solution strength is 100 milligrams in 40 mLs NS. They want us to find the microgram per minute range. They want us to find the range in ml per hour, and they want us to find the stabilizing dosage in mcg per minute. So there's a ton of information here. We are going to start with the weight. So I don't need to divide by 2.2 because it's already in kilograms. But I am going to set it up in a proportion with the rate that also has kilograms. And that's right here. So I'm going to take 103.7 times 5 and 103.7 times 8, and we get 518.5 to 829.6 micrograms per minute. So we have the range in microgram per minute, and they want us to find the range in milliliters per hour. So I need to set up this answer in a proportion with the solution strength. So the solution strength is 100 mg over 40 ml. And there's two things I need to do before I solve this proportion. I want to convert the 100 mg to 100,000 mcg, and I want to multiply the range by 60 because this range was per minute, and now we want it to be per hour. So I'm going to take 40 times 518.5 times 60 divided by 100,000. And if I round that to the nearest whole number, then we get 12. And then 40 times 829.6 times 60 divided by 100,000. And if we round that to the nearest whole number, we get 20. So this is 12 to 20 ml per hour. So what that means is we start the machine at 12, and if that doesn't work, we bump it up to 13, and we keep increasing it until it works. And here, for this question, it works at 14 mLs per hour. So that's kind of our first check that we're doing this correct, is that 14 does lie within this range. And that's also where I'm going to start the second half of my problem. Is I want to find the stabilizing dosage in mcg per minute. So we have the stabilizing dosage, but it's in mLs per hour. So I need to set that up in a proportion with the solution strength. (14 times 100 divided by 40), and we get 35. So this is milligrams per hour. But again, for the final answer, it needs to be in micrograms per minute. So we need to do two things. We need to convert from milligrams to micrograms. So I'm moving the decimal place over 3 places. And then I need to divide by 60. And round to the nearest tenth. And that will get us 583.3 micrograms per minute. And we know that this one is most likely correct because this lies within the 518.5 to 829.6 microgram per minute range. Also, when checking over your answers, it should be consistent. So the 14 mLs per hour, that lies between 12 and 20, but it is closer to the 12. And the 583.3, that lies within this range, but it's closer to the 518.5. So it should be consistent. And then, again, the last check is, did you use the solution strength twice? And we did.